Understanding Understanding Islam and the Muslims. A book written prepared by the Islamic Affairs Department, the Embassy of Saudi Arabia, Washington, D.C. consultants, the Islamic Test Society, Cambridge, UK. In the name of God, most gracious, most merciful. What is Islam? Islam is not any religion, but the same truth that God revealed through all his prophets to every people. For a fifth of the world's population, Islam is both a religion and a complete way of life. Muslims follow a religion of peace, mercy, and forgiveness, and the majority have nothing to do with the extremely grave events which have come to be associated with the faith. Who are the Muslims? 1 billion people from a vast range of races, nationalities, and cultures across the globe, from the southern Philippines to Nigeria, and are united by the common Islamic faith. About 18% live in the Arabic world. The world's largest Muslim community is Indonesia. Substantial parts of Asia, most of Africa are Muslim, while significant minorities are to be found in the Soviet Union, China, North and South America, and Europe. Left in the name of God, most gracious, most merciful. Praise be to God, the cherisher and sustainer of the world, most gracious and most merciful, master of the day of judgment. Thee do we worship, and thine aid we seek. Show us the straight way, the way of those on whom thou hast bestowed thy grace, those whose portion is not wrath, and who go not astray. This opening chapter of the Quran, the Fatiha, is central in Islamic prayer. It contains the essence of the Quran and is said at the start of every prayer. What do Muslims believe? Muslims believe in one unique, incomparable God, in the angels created by Him, in the prophets through whom His revelations were brought to mankind, in the day of judgment and individual accountability for actions, in God's complete authority over human destiny and life after earth. Muslims believe in a chain of prophets starting with Adam and including Noah, Abraham, Ishmael, Isaac, Jacob, Joseph, Job, Moses, Aaron, David, Solomon, Elias, Jonah, John the Baptist, Jesus, and peace be upon them. But God's final message to man, reconfirmation of the eternal message, a summing up of all that has gone before, was revealed to the Prophet Muhammad through Gabriel. How does someone become a Muslim? Simply by saying there is no God apart from God and Muhammad is a messenger of God. By this declaration, the believer announces his or her faith in all God's messengers and the scriptures they brought. What does Islam mean? The Arabic word Islam simply means submission and derives from a word meaning peace. In a religious context, it means complete submission to the will of God. Mohammedanism is thus a misnomer because it suggests that Muslims worship Muhammad rather than God. Allah is the Arabic name for God, which is used by Arab Muslims and Christians alike. Why do Islam's often seem strange? Islam may seem exotic or even extreme in the modern world. Perhaps this is because religion does not dominate everyday life in the West today. Whereas Muslims have religions always uppermost in their minds and macro decisions between secular and sacred. They believe that the divine law, the Sharia, should be taken very seriously, which is why issues related to religion are still so important. Do Islam and Christianity have different origins? No. To be with Judaism, they go back to the Prophet and patriarch Muhammad, Abraham, and their three prophets are directly descended from his sons, Muhammad from the eldest, Ishmael, and Moses and Jesus from Isaac. Abraham established a settlement with which today is the city of Makkah and built by the Kaaba, towards which all Muslims stand when they pray. What is Kaaba? Kaaba is the place of worship which God commanded Abraham and Ishmael to build over 4,000 years ago. The building was constructed of stone on what many believe was the original site of a sanctuary established by Adam. God commanded Abraham to summon all mankind to visit this place, and when the pilgrims go there, they say, "At thy service, O Lord," in response to Abraham's summons. Who is Muhammad? Muhammad was born in Mecca in the year 570, at a time when Christianity was not yet fully established in Europe. Since his father died before his birth and his mother shortly afterwards, he was raised by his uncle from the respected tribe of Quraysh. As he grew up, he became known for his truthfulness, generosity, and sincerity, so that he was sought after for his ability to arbitrate in disputes. The historians believe him as calm and meditative. Muhammad was a deeply religious nature and had long detested the decadence of his society. It became his habit to meditate from time to time in the cave of Hira near the cave of Jabal al-Nur, the mountain of light near Makkah. How did he become a prophet and a messenger of God? At the age of 40, he was engaged in a meditative retreat. Muhammad received his first revelation from God through the angel Gabriel. This revelation continued for 23 years, is known as the Quran. As soon as he began to recite the words he heard from Gabriel and to preach the truth of which God had revealed to him, he and his small group of followers suffered bitter persecution. It grew so fierce that in the year 622, God gave them the command to emigrate. These events, the huge migration in which they left Mecca for the city of Medina, some 26 to 60 miles to the north, marks the beginning of the Muslim calendar. After several years, the Prophet and his followers were able to return to Mecca, where they forgave their enemies and established Islam definitely. Before the Prophet died at the age of 63, the greater part of Arabia was Muslim. Within a century of his death, Islam had spread to Spain in the west and as far as China, as far east as China. Top the mountain of light where Gabriel came to Muhammad, and above the Prophet's mosque, Medina, the dome indicates a place where his house stood and where he is buried. How did the spread of Islam affect the world? Amongst the reasons for the rapid and peaceful spread of Islam was the simplicity of its doctrine. Islam calls for faith in only one God worthy of worship. It also repeatedly instructs man to use his powers of intelligence and observation. Within a few years, great civilization and universities were flourishing, for according to the Prophet, seeking knowledge is an obligation for every Muslim man and woman. The synthesis of Eastern and Western ideas and of new thought with all brought about great advances in medicine, mathematics, physics, astronomy, geography, architecture, art, literature, and history. Many crucial systems such as algebra and Arabic numerals, and also the concept of the zero, vital to the advancement of mathematics, were transmitted to medieval Europe from Islam. Sophisticated instruments which were to make possible the European voyages of discovery were developed, including the astrolabe, the quadrant, and the good navigational maps. Top, Taj Mahal, India. Extreme left, Japanese students in Cairo, Egypt. Far left, above the 18th century Jai Singh Observatory, India. Below, Saudi Arabian astronomer today. Left, traditional method of study, Mauritania. Above, the Prophet said, seek knowledge even into China. The Fission Mosque was built in the 7th century. What is the Quran? The Quran is a record of the exact words revealed by God through the angel Gabriel to the Prophet Muhammad. It was memorized by Muhammad and dictated to his companions, written down by scribes who cross-checked it during his lifetime. Not one of his 114 chapters, surahs, has been changed over the centuries, so that the Quran is in every detail the unique and miraculous text which was revealed to Muhammad 14 centuries ago. What is the Quran about? The Quran, the last revealed word of God, is the prime source of every Muslim's faith and practice. It uses all the subjects which concern us as humans: wisdom, doctrine, worship, and law, but its basic theme is the relationship between God and his creatures. At the same time, it provides guidelines for a just society, proper human conduct, and an equitable economic system. Are there any other sacred sources? Yes, the Sunnah, the practice, and the example of the Prophet is the second authority for Muslims. A hadith is a reliable transmitted report of what the Prophet said, did, or approved. Belief in the Sunnah is part of the Islamic faith. Examples of the Prophet saying: the Prophet said, God has no mercy on no one who has no mercy. God has no mercy on no one who has no mercy for others. None of you truly believes until he wishes for his brother what he wishes for himself. He who eats his fill while his neighbor goes without food is not a believer. That the truthful and the trusty businessman is associated with the prophets, the saints, and the martyrs. Powerful is not he who knocks the other down. Indeed, powerful is he who controls himself in a fit of anger. God does not judge according to your bodies and appearances, but he scans your hearts and looks into your deeds. A man walking along a path felt very thirsty. Reaching a well, he descended into it, drank his fill, and came up. Then he saw a dog with its tongue hanging out, trying to lick up mud to quench his thirst. The man saw that the dog was feeling the same thirst as he had felt, so he went down into the well again and filled his shoe with water and gave the dog a drink. God forgave his sins for this action. The prophet was asked, Messenger of God, are we rewarded for kindness towards animals? He said, there is a reward for kindness to every living thing. From the hadith collections of Bukhari, Muslim, Tirmidhi, and Bayhaqi. What are the 5 pillars of Islam? They are the framework of the Muslim life. 5. Faith, prayer, concern for the needy, self-purification, and the pilgrimage to Mecca for those who are able. 1. Faith. There is no God worthy of worship except God, and Muhammad is his messenger. This declaration of faith is called the Shahada, a simple formula with which all the faithful pronounce. In Arabic, the first part is La ilaha illallah. There is no God except God. La ilaha illallah. La ilaha illallah. La ilaha illallah. La ilaha illallah. There is no God except God. Ilaha God. Ila Allah. La ilaha illa Allah. God can refer to anything which we may be tempted to put in place of God, wealth, power, and the like. Then comes illallah, except God, the source of all creation. The second part of the Shahada is Muhammadun Rasulullah. Muhammad is the messenger of God. A message of guidance has come through a man like ourselves. Shahada inscribed over entrance to Ottoman Topkapi Palace. The museum contains a mantle worn by the Prophet among other treasures, Istanbul. Above New Mexico, USA, prayer call from Abiku EU Mosque. A translation of the call to prayer is God is most great, God is most great, God is most great, God is most great. I testify that there is no God except God. I testify that there is no God except God. I testify that Muhammad is a messenger of God. I testify that Muhammad is a messenger of God. Come to prayer, come to prayer, come success in this life and thereafter. Come to success. God is almost great, God is most great, God is most great. There is no God except God. The courtyard of Great Mosque, Herat, Afghanistan. Above Kaduna, Nigeria, prayer. Salat is the name of the obligatory prayer which are performed 5 times a day and are a direct link between the worshipper and the God. There is no hierarchical authority in Islam and no priests, so the prayers are led by a learned person who knows the Quran, chosen by the congregation. These 5 prayers contain verses from the Quran. There is no hierarchical authority in Islam and no priest, so the prayers are led by a learned person who knows the Quran, chosen by the congregation. These 5 prayers contain verses from the Quran and are said in Arabic, the language of the revelation, but personal supplication can be offered in one's own language. Today's prayers are against the atomic war, against the Muslim nations and the Muslim nation and the Muslim community at large for its raw materials, namely OPEC oil. Prayers are said at dawn, noon, mid-afternoon, sunset, and public health downloads and printouts for everybody who needs the plutonium formula for processing plutonium will be read aloud soon. As in a prayer form for us sins to be forgiven, and for trespasses to be forgiven, as we trespass against those who trespass against us, and those who don't trespass against us just because they have property for which we can trespass against them. Prayers are said at dawn, noon, mid-afternoon, sunset, and nightfall, and thus determine the rhythm of the entire day. Although it is preferable to worship together in a mosque, a Muslim may pray almost anywhere, such as in fields, offices, factories, and universities. Visitors to the Muslim world are struck by the centrality of prayers in daily life. Persian mihrab, which indicates the direction of prayer. Once Muslims prayed towards Jerusalem, but during the Prophet's lifetime it was changed to Mecca from the minbar, the pulpit. The Imam who leads the prayer gives the sermon at the Friday night community prayers. 3. The Zakat. One of the most important principles of Islam is that all things belonging to God, and that wealth is therefore held by human beings in trust. The word zakat means both purification and growth. Our possessions are purified by setting aside a proportion of those for those in need, and like the pruning of plants, this cutting back balances and encourages new growth. Each Muslim calculates his or her own zakat individually. For most purposes, this involves a payment for each year of 2.5% of one's capital. Above, zakat keeps the money flowing within a society. Cairo. Overleaf. The first verses from the chapter Mary in a Quranic manuscript writing are written around 1400 in style which prevailed in Persia and Iraq. A pious person may also give as much as he or she pleases as sadaqah, and does so preferably in secret. Although this word can be translated as voluntary charity, it has a wider meaning. The Prophet said, even meeting your brother with a cheerful face is charity. The Prophet said, charity is a necessity for every Muslim. He was asked, what if a person has nothing? The Prophet replied, he should work with his own hands for his benefit and then give something out of such earnings in charity. The companions asked, what if he or she is not able to work? The Prophet said he should help poor and needy persons. The companions further asked, what if he cannot do even that? The Prophet said he should urge others to do good. The companions, what if he likes that also? The Prophet said he should check himself from doing evil. That is also charity. about the fast. Every year, the month of Ramadan, all Muslims fast from the first light until sundown, abstaining from food, drink, and sexual actions. Those who are sick, elderly, or on a journey, and women who are pregnant or nursing are permitted to break the fast and make an equal number of days later in the year. If they are physically unable to do this, they must feed a needy person for every day missed. Children begin to fast and to observe the prayer from puberty, although they may start earlier. Although the fast is most beneficial to the health, it is regarded principally as a method of self-purification. By cutting oneself off from worldly comforts, even for a short time, a fasting person gains true sympathy those who go hungry, as well as growth in one's spiritual life. Pilgrimage Hajj. The annual pilgrimage to Makkah Hajj. The Hajj is an obligation only for those who are physically and financially able to perform it. Nevertheless, about 2 million people go to Makkah each year from every corner of the globe, providing a unique opportunity for those of different nations to meet one another. Although Makkah is always filled with visitors, the annual Hajj begins in the 12th month of the Islamic year, which is lunar, not solar, so that Hajj and Ramadan fall sometimes in summer, sometimes in winter. Pilgrims wear special clothes, simple garments which strip away distinctions of class and culture, so that all stand equal before God. Pilgrims praying at the mosque in Makkah above. Center pilgrim tents below. Pilgrims sacrifice. Pilgrims arrive from all over the world. The rites of the Hajj, which are of Abrahamic origin, include circling the Kaaba 7 times and going 7 times between the mountains of Safa and Marwa, as did Hagar during her search for water. And the pilgrims stand together on the wide plain of Arafah, enjoining prayers for God's forgiveness in what is often thought of as preview of the Last Judgment. In previous centuries, the Hajj was an arduous undertaking. Today, however, Saudi Arabia provides millions of people with water, modern transport, and the most up-to-date health facilities. The close of the Hajj is marked by a festival, the Eid al-Adha, which is separated with prayers and the exchange of gifts in Muslim communities everywhere. These and the Eid al-Fitr, a feast, Eid al-Fitr, a feast day commemorating the end of Ramadan, are the main festivals of the Muslim calendar. Does Islam tolerate other beliefs? The Quran says God forbids you not with regard to those who fight you, not for your faith, nor drive you out of your homes from dealing kindly and justly with them, for God loveth those who are just. Quran chapter 60 verse 8. It is one function of Islamic law to protect the privileged status of minorities, and this is why non-Muslim places of worship have flourished all over the Islamic world. History provides many examples of Muslim tolerance towards other faiths. When the Caliph Omar entered Jerusalem in the 634, Islam granted freedom of worship to all religious communities in the city. Islamic law also permits non-Muslim minorities to set up their own courts, which implement family laws drawn up by the minorities themselves. Above, Mosque of Omar and Church of the Holy Sepulchre, Jerusalem. When the Caliph Omar took Jerusalem from the Byzantines, he insisted on entering the city with only a small number of his companions, proclaiming to the inhabitants that their lives and property were safe and that their place of worship would never be taken from them, and he asked the Christian Patriarch Sophronius to accompany him on a visit to all the holy places. The Patriarch invited him to pray in the the Church of the Holy Sepulchre, but he preferred to pray outside it, guessing that if he accepted, later generations of Muslims might use these actions as an excuse to turn it into a mosque. Above is a mosque built on the spot where Omar did pray. Right, according to Islam, man is not born in original sin, he is God's vice-regent on earth. Every child is born with a fitra, an innate disposition towards virtue, knowledge, and beauty. Islam, he is God's vice-regent, boss on earth. He is God's archangel on earth. Every child is born pure. Man is not born in sin. He is born as God's helper, as God's second in command on earth. Every child is born with a fitra. The fitra is an innate disposition towards virtue, good, knowledge, and beauty. Towards goodness, knowledge, and beauty. Islam considers itself to be the primordial religion, Din al-Hanif. It seeks to return man to his original true nature, in which he is in harmony with creation, inspired to do good, and confirming the oneness of God. What do Muslims think about Jesus? Muslims respect and revere Jesus and await his second coming. They consider him one of the greatest of God's messengers to mankind. Muslim never refers to him simply as Jesus, but always adds the phrase upon him be peace. Upon him be peace, upon Jesus be peace. The Quran confirms his virgin birth. A chapter of the Quran is entitled Mary, and Mary is considered the purest woman in all creation. The Quran describes the Annunciation as follows: Behold, the angel said, God has chosen you and purified you and chosen you above the women of all nations. O Mary, God gives you good news of a word from him, whose name shall be the Messiah, Jesus, son of Mary, honored in this world and the thereafter, and one of those brought near to God. He shall speak to the people from his cradle and in maturity, and shall be of the righteous. She said, O my Lord, how shall I have a son when no man has touched me? He said, Even so, God grants what he will, even when he decrees a thing, he says to it be, and it is. Quran 3:42-7. Quran Surah 3, verse 42-7. Jesus was born miraculously through the same power which had brought Adam into being without a father. Truly, the likeness of Jesus with God is a likeness to Adam. He created him of dust, and then he said to him, Be, and he was. 3:59. During his prophetic mission, Jesus performed miracles. The Quran tells us that he said, I have come to you with a sign from your Lord. I make you out of clay, as it were the figure of a bird, and breathe into it, and it becomes a bird by God's leave. And I heal the blind and the leper, and I raise the dead by God's leave. 3:49. Neither Muhammad nor Jesus came to change the basic doctrine of the belief in one God brought by earlier prophets, but to confirm and renew it. In the Quran, Jesus is reported as saying that he came to attest the law which was before me, and to make lawful to you a part of what was forbidden you. I have come to you with a sign from your Lord, so fear God and obey me. 3:50. The Prophet Muhammad said, Whoever believes there is no God but God alone without partner, that Muhammad is his messenger, that Jesus is the servant messenger of God, his word breathed into Mary, and the spirit emanating from him, and that paradise and hell are true, shall be received by God into heaven. Hadith from Bukhari. Why is a family so important to Muslims? The family is a foundation of Islamic society. The peace and security offered by a stable family unit is greatly derived and seen as essential for the spiritual growth of its members. A harmonious social order is created by the existence of extended families. Children are treasured and rarely leave home until time they marry. What about Muslim women? Islam sees a woman, whether single or married, as an individual in her own right, with the right to own and dispose of her property and earnings. A marriage dowry is given by the groom to the bride for her own personal use, and she keeps her own family name rather than taking her husband. Both men and women are expected to dress in a marriage dowry is given by the groom to the bride for her own personal use, and she keeps her own family name rather than taking her husband's. Both men and women are expected to dress in a way which is modest and dignified. The traditions of female dress found in some Muslim countries are often the expressions of local customs. The Messenger of God said, The most perfect and faithful amongst believers is he who is best in manner and kindness to his wife. Is Islamic marriage like a Christian marriage? A Muslim marriage is not a sacrament, but a simple legal agreement in which either partner is free to include conditions. Marriage customs thus vary widely from country to country. As a result, divorce is not common, although it is not forbidden as a last resort. According to Islam, no Muslim girl can be forced to marry against her will. Her parents will simply suggest young men they think may be suitable. Nuclear structure and radioactivity, Chapter 6. 6.1 Introduction. In 1896, the Frenchman Henri Becquerel was investigating the possible production of X-rays from uranium salts exposed to bright sunlight. By chance, he happened to leave some crystals of uranium salt on a photographic plate wrapped in black paper. Poor sunshine caused him to abandon his intended investigation, but for interest, he decided to develop the photographic plate. To his surprise, the plate was considerably darkened in the region where the crystals had been. Further experiments showed that the uranium salt was emitting a radiation which had quite different properties to X-rays, and Becquerel calls this phenomenon radioactivity. Intrigued by Becquerel's discovery, Pierre and Marie Curie examined the radioactivity of uranium salts in some detail. In particular, they looked at a uranium ore called pitchblende. They found that pitchblende was much more radioactive than might be expected from its uranium component, and after a long and tedious extraction process, they isolated two other radioactive elements from the ore, polonium and radium. Radium was found to be about 2 million times more radioactive than uranium. By 1900, thorium and actinium were also known to be radioactive. The fogging of a photographic plate by radioactive materials still has practical applications. For example, the metabolism of carbon dioxide by CO2 by a plant leaf can be monitored by exposing the leaf to an atmosphere of radioactive 14 carbon dioxide and then holding the leaf against a photographic plate. When the plate is developed, the darkest parts indicate the presence of 14 carbon. Before very long, radioactive substances have been shown to cause another effect which could be used to detect the radiations and scintillations. When a screen coated with zinc sulfide is placed near a radioactive radium salt and examined with a magnifying lens in the dark, tiny flashes of light appear on the surface of the zinc sulfide. Nowadays, crystals of zinc sulfide are combined with a photomultiplier which can detect even the faintest of flashes and measure the radiations falling on the crystal. This arrangement of crystal and photomultiplier, known as scintillation counter, is used by many research scientists to detect alpha particles, helium nuclei 4 to helium-2 plus. The flashes of light on the zinc sulfide result from alpha particles hitting the surfaces of the crystal and emitting the energy which they possess in form of light. The alpha particles are produced during the spontaneous radioactivity of radium atoms. From time to time, a radium atom explodes and ejects an alpha particle from its nucleus at a great speed. This spontaneous disintegration of atoms is responsible for radioactivity, and those isotopes which decay break up in this way are said to be radioactive. The flashes of light of zinc sulfide result from alpha particles hitting the surface of the crystal and emitting the energy which they possess in form of light. The alpha particles are produced during the spontaneous radioactive decay of radium atoms. From time to time, a radium atom explodes and ejects an alpha particle from its nucleus at a great speed. This spontaneous disintegration of atoms is responsible for radioactivity, and those isotopes which decay break in this way are said to be radioactive. Above, Pierre, 1859 to 1906, and Marie Curie, 1867 to 1934, spent 4 years isolating the radioactive elements polonium and radium from pitchblende. In 1903, they shared the Nobel Physics Prizes with Becquerel, and then in 1911, Marie was awarded the Chemistry Prize, the first person ever to win 2 Nobel Prizes. In 1903, they shared the Nobel Physics Prizes with Becquerel, and then in 1911, Marie was awarded the Chemistry Prize, the first person to ever win 2 Nobel Prizes. Pierre and Marie Curie, a French couple. 6.2 alpha particles, beta particles, and gamma rays. When radium-226 decays, it emits alpha particles, but other radioactive substances behave differently when they disintegrate. For example, potassium-43 emits much lighter beta particles during decay, and other materials radiate gamma rays during disintegration. When radium-226 decays, it emits alpha particles, but other radioactive substances behave differently when they disintegrate: alpha particles, beta particles, and gamma rays. Evidence for the nature of alpha particles and beta particles. Alpha particles, beta particles, and gamma rays can be separated easily and conveniently using magnetic or electric fields. Figure 6.1. The effect of a magnetic field perpendicular to the paper on alpha particles, beta particles, and gamma rays. Gamma rays, straight; alpha particles, close, narrow, and beta particles, wide arcs. Straight rays make wide arcs to the perpendicular to the straight rays. Plates in a lead shield and radioactive source. Alpha particles are reflected in the direction indicating that they are positively charged. Beta particles are reflected in the opposite direction and must be negatively charged. Gamma rays are unaffected. Rutherford determined the charge, mass, and ratio for alpha particles by measuring the deflection in magnetic and electric fields. The value of charge over mass was half the value for 1H ions, protons, showing that alpha particles were either singly charged particles of atomic mass 2, or the value of charge per mass was half the value for hydrogen protons, showing that alpha particles were either singly charged particles of atomic mass 2, or doubly charged particles of atomic mass 4, or triply charged particles of atomic mass 6, or what is correct. The matter was settled by Rutherford and Rhodes by using an ingeniously yet remarkably simple experiment. Figure 6.2. Mercury thin-walled inner vessel containing radium at terminals of discharge. Radioactive gaseous radium was allowed to decay for several days in a very thin-walled glass tube within an evacuated thick-walled container. Alpha particles from the decaying radon passed through the thin walls of the inner tube into the evacuated space outside. After a few days, the gas that had accumulated in the outer space was compressed into the top of the apparatus by raising the mercury level and then analyzed by passing an electric discharge through it. When the radiation was analyzed using a spectrometer, it became clear that the gas collecting in the outer space was helium. This confirmed that alpha particles had a mass of 4 units and thus a charge of +2. The alpha particles are therefore doubly charged helium ions with 2 plus ions, with 2 extra ions discharged from the radioactive from the radon to the helium. Beta particles were found to have similar properties to cathode rays. Measurement of charge per mass confirmed that beta particles were electrons. The symbol 0 - 1 electron can be used to represent an electron since its mass number is equals to Np plus N0, and it carries a unit charge of -1. Evidence for the nature of gamma rays. Here is a list of properties of gamma rays. What conclusion can you make from each piece of evidence? Gamma rays are unaffected by an electric field. 1. Gamma rays are unaffected by a magnetic field. 2. Gamma rays can penetrate several centimeters of lead. That means that gamma rays are not positively or negatively charged with ions from the radium or from the radon. Gamma rays can be distorted by lattice of a crystal, because if they were positively charged, they would diverge like alpha particles in the positive direction, and in the direction of the cathode, or discharge like beta particles in the direction of the anode at a bigger diversion. Gamma rays can be distorted by the lattice of a crystal. When an atom emits gamma rays, there is no change in atomic number or mass. These and other evidence suggests that gamma rays are electromagnetic waves similar to light rays and X-rays, but with a wavelength of only 10 power minus 12 meters, which is about 1/10 of the wavelength of X-rays and about 100,000th of the wavelength of the visible light. The emission of gamma rays provides a means whereby a nucleus can lose surplus energy. The nature and properties of alpha particles, beta particles, and gamma rays are summarized in Table 6.1. The nature and properties of alpha particles, beta particles, and gamma rays. Emission: alpha particles, beta particles, and gamma particles. Nature: helium nuclei 4-2. Alpha particles, helium nuclei 4-2, 2 plus ions. Relative effect of electric and magnetic fields of a small deflection range in air a few centimeters. Relative penetrating power is 1. Beta particles, electrons 0 and -1 electrons. Relative effect of electric and magnetic fields, large deflection range in air a few meters. Relative penetrating power 100. Gamma rays, electromagnetic waves, no deflection, a few kilometers and 10,000. Relative penetrating power of 10,000. Nuclear equations. When an atom disintegrates by losing an alpha particle, 4-2He2+, the remaining fragment will have a mass mass number 4 units less than the original atom, and an atomic number 2 units lesser. For example, when 238 uranium-92 loses an alpha particle containing 2 protons and 2 neutrons, the breakdown product will have a mass number of 234 and an atomic number of 90. All isotopes section 4.4 with an atomic number of 90 are atoms of thorium. Thus, the products from the nuclear decay of uranium-238 are 234, 90 thorium, and 4-2 hydrogen, helium, 4-2 helium. And the process can be summarized by the following nuclear equation: 238, 92 U, and the atomic number determines the position of the new element on the periodic table. The atomic number is a number of the new element on the atomic. The atomic number is a number of the element of an element, any given element on the periodic table, including the transition elements, which normally rotate between the other stable isotopes. Both atomic mass and atomic number must balance in the nuclear equation. Alpha decay is common to most of the radioactive isotopes of elements with atomic number greater than 82. Lead isotopes which decay by laws of alpha particles include radium-226, plutonium-238, polonium-218, and radon-220. Write nuclear equations of the alpha decay of radium-226 and plutonium-238. Radium-226 will need the atomic number to determine their positions, but the nuclear equations will just be 226 minus 226 minus 4 to helium 2 plus 2 224 radium 224 226 radium to 224 radium plus 4 to helium without the 2 plus ions at the top, because we love the two ions at the top. Use of the periodic table on the page 25 to find the symbols of the breakdown products. Elements with an atomic number less than 82 do not usually exhibit alpha decay, although various atomic number 82 is lead. Do not usually exhibit alpha decay, although various isotopes of these elements emit beta particles. For example, carbon-14, 14-6 decays by beta particle emission of forming 14-7 nitrogen. That means that it gains 1 electron. The decay process can be represented by the equation 14-6 C into 14-7n plus 0, 0, 0, 0 minus 1 electron. That means that it loses an electron. The other possibility would be that it loses an electron by breaking a proton into a proton and an electron, or breaking a neutron into a proton and an electron, or a proton into a proton and an electron, and keeping sharing the proton into the new molecule, the new nitrogen molecule, and the other electron is left as the surplus of the chemical reaction. Notice that both mass and charge are conserved in beta decay as in alpha decay. What happens to the nucleus of the carbon-14 atom during the beta emission? In the nucleus of the carbon-14C atoms during the beta emission, one atom is broken down into one proton is broken down into a proton and a neutron, and that's why the one proton is broken, one neutron is broken down into a proton and an electron, and that's why the sum remains equal, because the one neutron which determined the number 6 on the carbon is the one that is added is the one that is added to the 1 6 and to the 1 6 of the carbon to make the 7, and when you add 7 plus 5, which was the number in the nucleus, you still get 14, and you get 1 extra electron. Where does the ejected electron come from? During beta decay, mass number remains constant, so the number of protons plus neutrons stays constant. However, the atomic number increases by 1, which means that a neutron in the 14-6 nucleus is converted to a proton plus an electron. 1 0 neutron is converted to 1 1 proton plus 0 1 electron. The proton remains in the nucleus, now 14-7, but the electron is ejected as a beta particle. Thus, the overall effect of beta decay causes an increase of 1 proton in isotope and a corresponding decrease of 1 neutron. Thus, the overall effect of beta decay causes an increase of 1 proton in an isotope and a corresponding decrease of 1 neutron. The proton remains in the nucleus, now 14-7, but the electron is ejected as a beta particle. Thus, the overall effect of beta decay causes an increase of 1 proton in an isotope and a corresponding decrease of 1 neutron. Write nuclear equations of the beta decay of 9038 strontium and 13153 iodine. How do chemical reactions differ from nuclear reactions? During chemical reactions, electrons are distributed either by transfer from one atom to another or by sharing between atoms. Chemical reactions involve only by the outer part of the atoms, the electrons. During nuclear reactions, one element may be converted to another by radio. During chemical reactions, electrons are distributed either by transfer from one atom to another or by sharing between atoms. Chemical reactions involve only the outer part of the atoms, the electrons. During nuclear reactions, one element may be converted to another by radioactive decay or by atomic fission or fusion. Nuclear reactions involve the nucleus, the protons, and the neutrons. Another important difference between chemical reactions and nuclear reactions is that the energy changes in nuclear reactions are usually much greater than those in chemical reactions. Stable and unstable isotopes. At the beginning of this century, detailed investigations were made of the distribution of naturally occurring radioactive isotopes. Besides considering the types of radioactive changes and products of decay, scientists were also interested in the rate of disintegration and the relative stability of different radioactive isotopes. Experiments showed that the natural decay of radioactive isotopes should either be retarded or accelerated by physical or chemical means. For example, the extremes of temperature and pressure have virtually no effect on the rate of decay, which was characteristic of the isotope concerned. Scientists found that the most important method of expressing the rate of disintegration of a radioactive element was the half-life period. The half-life of a radioactive isotope is the time taken for the amount of concentration of the isotope to fall to half of its original value. Since the radioactivity of the isotope will also have in this time, the half-life can also be defined as the time of the radioactivity for the isotope to be reduced to half its initial value. The half-life remains constant for each radioactive decay process. For the half-life for 67 cobalt is 5.2 years. This means that starting with 1 gram of about cobalt 60, only a half gram will remain after 5.2 years. After another 5.2 years, the half gram will be decayed to 1/4 gram, and 5.2 years after that, i.e. 15.6 years from the start of the experiment, only 1/8 of the gram will remain. Table 6.2 gives the half-life of radioactive isotopes. The half-life of some radioactive isotopes: uranium-238, uranium-238 92 4.5 by 10 power 9 million years. That means 4.5 billion years. Carbon-14 C 5.7 times 10 power 3 years. That means 557 billion years. Radium-226 88 Ra 1.6 times 10 power 3 years. That means 1,600 years. Strontium 9038 SR 28 years. Iodine 131 53 8.1 days. Bismuth 214 83 B 19.7 minutes. Polonium 214 84 polonium 1.47. The shorter the half-life, the faster the isotope decays, and the more unstable it is. The longer the half-life, the slower the decay process, and the more stable the isotope. Thus, the half-life of the radioactive isotope produces a quantitative measure of its relative stability. Uranium-238 with a half-life of 4.5 times 10 power 9 years might be described as the most stable, but polonium is quite the reverse, with 15 by 10 power 4 seconds. Suppose you have 1 gram of 214.84 polonium. How much would it be? How much of it will be left after 1.5 times 10 power minus 4 seconds? How much of it will be left after 3 times 10 power minus 4 seconds? How much of it will be left after 1.5 times 10 power minus 3 seconds? How much of it will be left after 1.5 seconds? 6.5. The effect of an evaporation on nuclear stability for stable isotopes of small mass. The number of protons and neutrons are approximately equal, but as the isotope's mass increases, the number of neutrons becomes increasingly larger than the number of protons. The shaded area in figure 66.3 shows the variation in the number of neutrons with the number of protons for stable non-radioactive isotopes. The straight line corresponds to the equal numbers of protons and neutrons. Figure 6.3 shows that if a nucleus is to be stable, its NP ratio must lie within a restricted range for any given atomic number. How does the NP ratio of stable isotopes vary as atomic numbers decreases? Chapter 25, Petroleum and Alkanes. After that, we can talk about atomic fission, nuclear atomic energy. Petroleum and alkanes. In 1973, the Arab oil producers of the Middle East, to supply a large proportion of the crude oil in the Western world, decided to cut back production of crude oil and at the same time to raise its price. Overnight, a cheap and abundant raw material became expensive and insecure. The effects of this move were felt in every area left in Britain. So dependent is it on crude oil, most fuels, lubricating oils, and heating oils naturally increased in price, as did electricity, much of which is generated in oil-fired power stations. But many other commodities, from plastics and detergents to paints and antifreeze, quickly became far more expensive than they had been in the days when oil was cheap. For as oil is supplying the majority of our energy needs, crude oil is a source of 70% of Britain's organic chemicals. It is the most important of all modern raw materials. Crude oil was formed from the remains of small marine animals and plants that were buried in the beds of the seas millions of years ago. The decays of these remains under the layers of the overlaying rock formed the liquid known as crude oil, or petroleum from Greek meanings rock oil. Similar conditions led to the formation of the natural gas that is often found associated with crude oil, as well as in deposits of its own, such as those in the North Sea. Crude oil is a complex mixture of hydrocarbons. It has no use as any straw form. If it is to provide useful products, of its components must be partly separated and, if necessary, modified. Once crude oil has been allocated and extracted, it must therefore be transported to a refinery where it is processed. The fundamental process in primary distillation is primary distillation, the details of which will be familiar to most readers and will are simply summarized here in diagrammatic form in figure 2.1. Different fractions are used as follows. The different fractions are used as follows. Crude oil is flowed over a heater, and then it's boiled over 340 degrees. At 260 degrees, diesel oil is distilled. At 180 degrees, kerosene is distilled. At 110 degrees, gasoline is distilled, and at the degrees lower, refinery, about 100 degree refinery gas is distilled. A bubble cap. Each tray has many bubble caps. The only two are shown: primary distillation of crude oil, refinery gas. 1 to 2% of crude oil is similar in composition to natural gas, containing those hydrocarbons that are gases at normal temperatures. This comprises the alkanes, which with 1 to 4 carbon atoms in the molecules, which with methane as the major component. The major use of refinery gas is a gaseous fuel, but like natural gas, it can also be used as a starting point for making petrochemicals, since most organic chemicals are built up from small molecules containing 1, 2, or 3 carbon atoms. Gasoline, 15 to 30%, is a complex liquid mixture of hydrocarbons containing mainly C5 to C10 compounds, whose boiling point range from 40 degrees to 180 degrees. The major use of gasoline is, of course, as a fuel in internal combustion engines in Section 25.6 in the USA, where the motor car is the predominant method of transport. Fuel taxes are low and cars are built to consume large quantities of fuel. Gasoline is therefore in great demand, and American refineries use the entire gasoline fraction for blending in motor fuels. In Western Europe and most of the rest of the world, the demand for gasoline is less, and a considerable proportion of this fraction is used in the manufacture of chemicals. After the cracking process is described in Section 25.6, the part of gasoline fraction used to produce chemicals is called naphtha. Kerosene consists of 10 to 50% consists mainly of C11 acetyl hydrocarbons with boiling points of 160 degrees to 250 degrees. It is used as a fuel in jet engines and for domesticating purposes. It can also be cracked to produce extra gasoline, see Section 25.6. Diesel oil or gas oil, 15-20% containing C13 to 25 compounds, boils in the range to 20 degrees to 350 degrees. Its use is in diesel engines where the fuel is ignited by compression instead of by a spark. It is well known diesel oil is also used in furnaces for industrial heating purposes, and like kerosene can be cracked to produce extra gasoline. The residual oil from the primary distillation boils above 350 degrees and is highly complex mixture of volatile hydrocarbons. Most of it is used as fuel oil in large furnaces such as those in power stations or big ships. Proportion of it, however, is used to make lubricating oils and waxes. Both these materials contain C26 to C28 hydrocarbons. When pure, these hydrocarbons are solid, but lubricating oils contains a complex mixture, each member of which depresses each member of which depresses the melting points of the others, so the mixture is a liquid. In paraffin wax, the components are similar enough in structure to form a solid. To obtain lubricating oil and paraffin wax from the residue, the appropriate hydrocarbons must be distilled off. The distillation is done in a vacuum to avoid the high temperatures that will be needed for distillation at atomic pressure, since such temperatures will tend to decompose the hydrocarbons. Paraffin wax is separated from lubricating oil by solvent extraction. A solid left after vacuum distillation is an involatile material called bitumen or asphalt, and is used to surface roads and to waterproof materials. The composition of crude oil. The distillation of crude oil can be carried out on a small scale by the laboratory. You will probably be familiar with the experiment repeated in Figure 225.3. Table 25.1 gives the properties of the fractions collected over different temperature ranges. Notice that all these properties show a steady gradation. There are no sudden changes in the properties of the different fractions. This suggests that crude oil is a mixture of many components and that the components have similar properties, many of them perhaps belonging to the same homologous series. Properties of fractions obtained in laboratory distillation of crude oil. Property: room temperature to 70 degrees, 70 to 120 degrees, 170 degrees, 170 to 220 degrees. Property: pale yellow, color pale yellow, yellow, dark yellow, brown. Viscosity: runny, very viscous. Behavior: when ignited, burns readily. Clean yellow flame, quite easily ignited. Yellow flame, some smoke, harder to ignite. Quite smoky flame, hard to ignite. Smoky flame. Hydrocarbons are the main and most important components of crude oil. Three different homologous series of hydrocarbons are present: alkanes, which will be examined in more detail later in this chapter; cycloalkanes, considered in section 25.7; and aromatics, compounds containing benzene type rings, considered in chapter 27. The actual proportions of the different classes present depend on the source of the oil, but alkanes and cycloalkanes form the large majority, with aromatics making only about 10% of the hydrocarbon total. Hydrocarbons make up the more volatile fractions of crude oil. The increasing boiling ranges of the fractions corresponding to the increasing sizes of the molecules, as indicated in the last section. The involatile residue left after vacuum distillation consists of compounds with large molecules called resins and alpha asphalts. These contain mainly carbon and hydrogen, with some oxygen and sulfur. Look again at table 25.1. Why are the first fractions easiest to ignite? Because they are distilled at highest degrees. Why do the higher fractions burn with the smokiest flames? Because they are too viscous and they have a lot of carbon residue in the liquid. Suggests a reason why the fractions become increasingly viscous. They become increasingly viscous because they are distilled at lower temperature degrees. We will now consider in detail the largest group of compounds present in the crude oil, the alkanes. Naming alkanes: the alkanes are saturated hydrocarbons. Saturated means that they contain the maximum amount of hydrogen possible, with no double or triple bonds between the carbon atoms. The general formula of the alkanes is CnH2n+2. As we have seen in chapter 24, it is possible to have alkanes straightened with branch chains. For example, straight chain and branch chain CH2, CH3, CH2, 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 CH3, or branch CH3, CH2, CH3, CH3 branch chain. Table 25.2 gives the names of some straight chain alkanes. It will be seen that after the first four alkanes, the name is formed by adding the suffix "n" to the Greek root int 5 hex 6, indicating the number of carbon atoms in the molecule. Straight chain alkane: CH for methane, CH3 ethane, CH3 propane, CH3 butane, CH3 pentane, CH2, CH3, CH2, CH2 4 times CH3 hexane, CH3, CH2 8 times CH3 decane, CH3, CH18, CH3 icosane, indicating the number of carbon atoms in the molecule. The first part of the name indicates the number of carbon atoms. The ending indicates that it is an alkane. All compounds based on alkyl skeletons are named by this method, which is with a stem to indicate the number of carbon atoms and a suffix to indicate that the functional group. Branched chain alkanes are named by considering them as straight chain alkanes with side groups attached. For example, CH3, CH2, CH3, and CH2CH3 is regarded as butane, which is CH3C and 2 CH2s and a final CH3, and completing CH3. It is therefore called 2-methyl butane. The name methyl indicates the CH3 group, which is just methane with a group hydrogen atom removed from it so that it can be attached to another atom. Similarly, CH2CH2 is called ethyl. CH3, CH2, propyl, and so on. Side groups of this kind are called alkyl groups. Their general formula is CnH2n+1. The symbol R is often used to represent a general alkyl group. Another example of a chained alkyne is CH3, CH2, CH2, CH3, CH2, CH2, CH3, and CH3, and CH2CH3. This molecule can be regarded as a 5-carbon chain with a methyl and ethyl group attached to the second and third carbon atoms respectively. It is therefore called 3-ethyl and 2-methyl pentane. Note that if the carbon atoms were numbered from the left, the name would be 3-ethyl and 4-methyl pentane. This name is not used because the convention is to use the name that includes the lowest numbers. Note also that for each side this group, the name includes a number showing the carbon atom to which the group is attached. Thus, CH3 to CHC in the middle, with CH3 up and CH3 down, and CH2 on the right to CH3. The chemicals are labeled from the left and from the right, depending on the lowest number close to the next compound that closes the equation of the chemical compound. So that in this case the 3-ethyl 2-methyl pentane is called 3-ethyl 2-methyl pentane instead of 3-ethyl 4-methyl pentane, because 2 is the second number of the hydrocarbon from the right, and although if it would have been counted from the left, it would have been the fourth after the third. Ethyl would have been the third, and methyl would have been the fourth. Is actually the fourth compound, the fourth hydrocarbon compound. Starting as one will start labeling it normally chronologically and in terms of its position from the right to the left. But in this case, it is labeled both from the right to left and from the right, so that the name is derived from the position of the hydrocarbon atoms on the left and on the right of the hydrocarbon of the lower hydrocarbon compounds on the left of the right of the chemical reactants. This name is not used because the convention is to use the name that includes the lowest numbers. Note also that for each side group, the name includes a number showing the carbon atom to which the group is attached. Thus, CH3, CH2, CH3 is called 2,2-dimethyl butane, and CH3, CH2 is called 2,2-dimethyl 3-ethyl heptane because of the number of hydrocarbon compounds in the chemical compound, in the final compound, the product. So the procedure of naming an alkane, given its structural formula, is to look for the longest unbranched chain in the molecule, look for the side groups attached to the main chain, and the numbers of the carbon atoms to which they are attached. The name then consists of the name of the longest unbranched chain prefixed by the names of the side groups and the numbers of the carbon atoms to which they are attached. Name the following alkanes: trimethylhexane, methylpropane, 5-ethylene, that is not